first position, the null hypothesis. Sorry, the first step is to define the hypothesis. So the hypothesis has a null position and an alternative position. The null position is that there is zero kurtosis, okay, or that the distribution is in fact isn't peaked and isn't flat. So that the kurtosis equals 0, okay. That's the null position. The alternative being that the kurtosis is not equal to 0, okay. We could actually do this is actually a two-tailed test, because all I need to show is that the kurtosis is greater than 0 or less than 0, and what we would have shown is that it's either platy or lepto. That makes sense. But we don't have to do this. We could do a one-tailed test if we want to, but I'm just going to concentrate on a two-tailed test. Step 2 is to define the significance level, the significance of our tests, the significance level, and for us we're just going to choose alpha is equal to 0.05. This has been run at the 5% significance level, which means that if we do find evidence to reject a null hypothesis, we'll be 95% confident in doing that, but we'll also keep in mind that we actually could be wrong, and what we're controlling for here is that probability of incorrectly rejecting a null when in fact it's actually true, and we're willing to accept doing that 5% of the time. So that's step 2. Step 3 is to define our test statistic. But before I can do that, I need to actually calculate what my standard error is. Okay, so my standard error for my kurtosis is equal to 24 times the sample size, which is 50, times the sample size minus 1, which is 49, which needs to be squared, and that needs to be divided by sample size minus 2, which is 48, times the sample size minus 3, which is 47, times the sample size plus 5, which is 55, times the sample size plus 3, which is 53, and it's the square root of that particular value here. I'm going to just do that all in one go on my calculator, if I can find my calculator. Oh, here it is. So I'm going to just do all that in one go on my calculator. So I need to calculate the square root. My numerator is 24 times 50 times 49, which needs to be squared, so times 49 again, and that needs to be divided by, it's 48 times 47 times 55 times 53, and this gives us a standard error of 0.6619. So this is approximately 0.6619. That's our standard error. Now we can actually calculate our test statistic. So our test statistic, Z of k, the Z score associated with this particular kurtosis value, is equal to our kurtosis, which is minus 0.3063, minus 0, and that's to be divided by our standard error, which we just calculated to be 0.6619. So we get Z of k is going to be negative, meaning it's going to be in the left-hand tail, okay? Which means it's evidence to suggest that it's less than 0. It's evidence to suggest that the distribution is in fact platykurtotic, okay? So we have it's negative 0.3063 minus 0, that doesn't make any, has no effect, and that needs to be divided by 0.6619, which gives us a value of minus 0.46778 to 4 decimal places. Okay, so now that we've got our test statistic, we can proceed to calculate our associated critical values. And let's just keep in mind here that our test statistic is a Z statistic, so our critical values are going to be associated with a standard normal curve. Okay, so step 4 is our critical values. Okay, and that's going to be associated with a standard normal curve. Okay, so let's just draw the standard normal curve. It's going to look something like this. It's a standard normal curve. It's centered on 0. And actually, if we think about it from a test statistic perspective, okay, if our evidence if our evidence was actually 0, okay, well then 0 minus 0, which is where we believe it should be, the distance would be 0 here, okay, in which case we'd have a Z statistic of 0, which is what the center of this distribution represents. The center of this distribution will represent that there is no, it's for a distribution that has no significant excess or in excess of kurtosis. In other words, it's like has the kurtosis of a normal distribution. Okay, so our test is a two-tailed test. I don't care whether the kurtosis is positive, as in evidence to suggest that it's leptokurtotic, or